Alright, this lesson is all about proving triangles congruent. We'll be talking about side, 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 angle, hypotenuse, leg, angle, side, and all that good stuff. Alright, but first of all, the congruence statement. If a triangle ABC is congruent to triangle DEF, the order of these letters matter. So that means that angle A is congruent to angle D. Alright, because those are both first in the order of things. So that means angle C is congruent to angle F, and angle B is congruent to angle E. Okay, and that works for the sides of the triangle as well. So side AB, alright, which is this bottom portion down here, is going to be congruent to side DE of the other triangle. And oh, you want to talk DF? Well, let's talk DF. Okay, so if this is DF, and then that's going to be congruent to AC. Okay, that's a little hard to see. And then this third one, which I really don't need a color for, but whatever. The third sides will be congruent as well. So CB and FE will be congruent. Okay, now given the following congruent triangles, write a congruency statement. I think it meant to say statement. So, this is very simple. Actually, maybe not so simple as I immediately thought, because if you just glance at this quickly, you might think the congruency statement would be triangle GBP is congruent to triangle AEO, like this. But guess what? You'd be wrong. This is incorrect. Okay, GBP, AEO, it looks nice, but take a little closer look. Look at how these are marked, okay? Alright, let's colorize this picture to help us see why this is wrong. Okay, you see the single mark here. Alright, we'll color that pink because we're visual people. Now, on this triangle, this is not the pink side, is it? Alright, the single mark over here is AO. So these two go together. Okay. Alright, please sir, can I have another? Why, yes you may. The double is BP. Okay, and on this one the double is AE. So those go together. And I guess I could just leave this one blue because blue is a color. But obviously the one that's left is GP, and that goes with EO. So look at the colors. So let's fix this. Angle G is formed by the pink and the blue. So over here, which angle is formed by the pink and the blue? That's angle O. Alright, so this really needs to be angle O. Alright, now we got B. B is formed by the pink and the green. Over here, the pink and the green form angle A. So that should be A. And of course, what's left is P, which is formed by the green and the blue. Over here, the green and the blue form angle E. Alright, so the correct congruency statement should be triangle GBP is congruent to triangle OAE. So you've got to be really careful. If you've got highlighter pens or something, it might be helpful. But even without the colors, you could think of it this way. Angle G is formed by the single and the triple. Okay, so you could look for which angle is formed by the single and the triple. And that's angle O. So you don't really need the colors. It just helps. So there's your correct congruency statement. Okay, so over here, if I want to talk about triangle ABC and make my congruency statement, okay, triangle ABC is congruent to. Now, angle A is nicely marked for us using with this green thing, and clearly that matches angle Z, so that's going to go first. Now, angle B is formed by the double and the nothing. So what angle is formed by the double and the nothing? That's X. And then angle C is formed by the single and the nothing. It's the angle that looks sort of like it might be a right angle, but we don't know that for sure. But anyway, the single and the nothing, that's angle Y. So there's your congruency statement. Alright, in each problem we're supposed to determine if each pair of triangles is congruent by side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. If they are, complete the congruence statement 2. If none of these methods work based on the information given, write none. Okay, so problem number 4. Here we have a side. We have two sides. Okay, we have two sides congruent to each other, and the angle that's in the middle. The angle that's in the middle. So when we have two sides and then the angle in the middle are congruent for both triangles, then that's called side, angle, side. Okay, so they are congruent. So specifically, triangle BIG is congruent to triangle FAJ. Number 5. Here we have three angles congruent to three angles of another triangle. There is no angle, angle, angle congruency postulate or theorem. Alright, because having three angles that are the same, that's enough to make sure that you have similar triangles, but you could have one triangle that's bigger than the other, and they would still have the same angles. So we will say none. And so this is not applicable. Alright, at a glance, for number 6, we have two angles and a side. So if we were rushing, we would not be sure. With two angles and a side, that could be angle, side, angle, or it could be angle, angle, side. But only one of these is correct. So which one is it? Well, if it's going to be angle, side, angle, it has to be two angles and then the side that's between them. Alright, if the side is not between the two angles, then it's angle, angle, side. Alright, because see how the S is not between the two A's? That's how you know. Okay, so look, here we have our two angles. Alright, we have an angle here and we have another angle here. Alright, that's given to be congruent. Alright, so the question is the side that we're given. Alright, we're given this side over here. Is that between these two angles? And the answer, of course, is no. Alright, this is the side that's between the two angles right here. But that's not the one that's marked congruent. So that means we need this is the correct answer, angle, angle, side, because the side is not between the two angles. Okay, so we'll go with angle, angle, side. Alright, and the congruency statement will be triangle OPN is congruent to triangle, let's see, O is congruent to D, P is congruent to W, and that leaves N to be congruent to E. Alright, here we have three sides marked congruent to three sides of another triangle. So that would be your side, side, side postulate, which is a thing that works. So they are congruent by the side, side, side. So triangle FLP is congruent to triangle. Alright, so these are sort of backward, so let's be careful. Angle F is formed by the single and the triple. Over here, the single and the triple, that's angle V. So, kabam. Angle L is formed by the double and the triple. Over here, the double and the triple form angle O, so that's next. So now we've done V and O, so that leaves R. Must be the third one. Alright, number 8 is hot. Hot. What we have here is we have two sides and an angle. Two sides and an angle. But we have to be careful because with two sides and an angle, that could be side-side angle, or it could be side angle side. Now, one of these is a theorem. The other one is not a theorem at all. So depending on which one of these it is, it could either be congruent or it could be not congruent. So how do we know whether it's side-side angle or side angle side? Well, if it's going to be side angle side, it has to be two sides and the angle, what we call the included angle, meaning the angle in between the two sides. Okay, so here we have the two sides, okay, here and here. And the angle that's marked congruent is this one. Is that the angle that's between these two sides? Is it the angle that's formed by these two sides? Yes. So that makes this side angle side. Okay, so for example, if they had given us this angle out here instead, that would be none. Anyway, the congruency statement, HOT. So again, we got to be a little bit careful because of the way these are rotated. But angle H is formed by the single and the nothing. So over here, the single and the nothing, that's angle D. All right, hold on, let me erase this. And then we're at O. Well, O is marked nicely for us as Y. So we have D, Y, and that leaves A. Alright, number 9, we have two angles and a side. So is this angle, angle, side, which is a theorem, or is it angle, side, angle, which is also a theorem? People mix this up all the time. Well, if it's going to be angle, side, angle, it has to be two angles and the side that's between them. So here we have an angle and here's the other angle. So the question is this the side that's between the two angles? Yes, it is. Alright, it is between the two angles. So that makes it angle, side, angle. So these are sort of backwards to each other, so be careful when you name them. So angle C is congruent to angle G. See the single marking and the single marking. So make sure you start off with G. And then angle L, alright, that's a double mark, is congruent to angle N. See the double mark. So now we've done G, N, so that leaves H left to be the third. Alright, number 10, we have a lot of information. Alright, we have more than 3 pieces of information. So we have all 3 angles marked congruent to all 3 angles. So that's interesting, but that's not a theorem. There's no angle, angle, angle theorem. But we also have a side marked as well. So what we have an angle, an angle, an angle, and a side. So depending on how it's set up, maybe we can get angle, angle, side out of it, or maybe we can do an angle, side, angle out of it. It just depends. So let's see what we can do with it. If we were going to do angle, side, angle, we would need 2 angles and the included side, meaning the side that's between the 2 angles. Do we have that? So if we look at here, we have the triple and the double. Okay, the triple and the double. Okay, and so let's do that over here. So here's the triple and here's the double. So the question is, do we have the side in between marked congruent? So this would be the side in between, and it is congruent. And this would be the side in between, and it is congruent. So we do in fact have angle, side, angle happening. Angle, side, angle. So there, we could go with that right now. Right, angle, side, angle. Now, could we do angle, angle, side? All right, do we have two angles and the non-included side? Yeah, we could look at it that way too, because we have this extra information. If instead of using the triple, okay, imagine that we instead focused on the single. Okay, so looking at these three pieces of information, now we have two angles and the non-included side, which is not between them. Two angles and the non-included side. So that would be angle, angle, side. So either one of those would work. Alright, either way, now let's make the congruency statement. So triangle CAT is congruent to triangle. Well, this should be easy because C is tripled marked, and that's M. And then A is the single mark, so that's S. And so we've done MS, so that leaves E. Okay, for number 11, we have two angles and a side. Two angles and a side. So that could be angle, angle, side, or is it angle, side, angle? Both of these involve two angles and a side, so which is it? Well, if it's going to be angle, side, angle, it has to be two angles and the included side. In other words, two angles and the side between them. So let's see if that's what we have. So here we have the angle and another angle. Now, is this, the side that's marked, is this between the two angles for angle, side, angle? No. This would be the angle that's between them, but that's not the one that's congruent. I'm sorry, this would be the side that's between them, but that's not the side that's marked congruent. So what we have is two angles and the non-included side. That's angle, angle, side. Alright, so the congruency statement. Angle H is the blank angle, and that's angle T. And then angle I is the single, and that's C. And now we've done TC, that leaves A to complete the congruency statement. Okay, something special about these triangles is that they are right triangles. And we do have this theorem that's called hypotenuse leg. So only a right triangle has a hypotenuse. So anytime we're given right triangles, we should first ask ourselves, is it hypotenuse leg? It's not guaranteed. But this single mark, is that a hypotenuse or a leg? Yeah, well, that's a leg. Okay, so we have a leg. This double mark, is this the hypotenuse? Well, yeah, it is the hypotenuse. Okay, it's across from the 90-degree angle. It's the largest side. So we are given a hypotenuse and a leg of one triangle congruent to the hypotenuse and the leg of the other triangle. So we can call these congruent by the hypotenuse leg theorem. And the congruency statement will be angle A is that's the double and the single. Okay, so here the double and the single is angle Z. Okay, and then B, that's the one that's across from the single. Okay, so the one across from the single here is X. So now we've done ZX, so that leaves Y, which of course is the 90-degree angle, which is the same as C. So it makes sense. Alright, number 13, we have another pair of right triangles. So first thing we will ask ourselves is, will this be covered by the hypotenuse leg theorem? Okay, so I see these two marks. This single, that's a leg. Alright, this double, that's another leg. The hypotenuse is over here, that is not marked congruent. So we have a leg and a leg, okay, but not the hypotenuse. So we will not be using the hypotenuse leg theorem. Alright, does that mean it's none? Well, not necessarily. Let's just treat it like any other triangle and see if it fits one of the other theorems. So, what we have then, if we just look at it like any other triangle, we have two sides and an angle. So maybe it could be side, side, angle, but wait a minute, that's not one of the theorems. Alright, if I wrote it the other way, that would make a bad word. Luckily, the one that makes a bad word is not a theorem, so good to know. So if not that, what else could I make out of this? It could be side, angle, side, which is a theorem. So to be this, I need two sides and the angle between them, or the angle that's formed by them, the included angle, we say. And what we have is we have a side here marked congruent to this side here, and this is the angle included, alright, the angle formed by those two sides. So we do have, in fact, side, angle, side theorem. So triangle ABC, okay, so we're going from here this time. So triangle ABC is formed by the double and the hypotenuse. So let's see, the double and the hypotenuse, that's E. Angle B is the 90-degree angle, so that's going to be congruent to F. Alright, so that leaves, so we've done EF, so that leaves D. So there's your congruency statement. Okay, I messed up my F, but we're going to live with it. Okay, we have two sides and an angle. Okay, again, two sides and an angle. Side-side angle is not a theorem. Alright, if I wrote it the other way in alphabetical order, it would make a bad word. Luckily, that's not a theorem. But maybe it's side, angle, side, because that would also be two sides and an angle. If it's going to be side, angle, side, though, I need two sides and the included angle, the angle that's between the two sides. So, is that what I have here? Well, so I have this side and I have this side. Okay, the included angle would be angle F. But that's not the angle that's marked congruent. It's this angle over here that's not formed by the two congruent sides. So this is not side, angle, side. Alright, if it was a theorem, it would be angle, side, side. But luckily it's not a theorem, so we're going to put none. And so this is not applicable. Okay, looking at these triangles, we have right triangles. So do we have hypotenuse leg syndrome theorem, I mean. So let's see. Well, let's go straight to the hypotenuse because I'm looking at it and there's nothing marked on it. So we do not have hypotenuse, so it cannot be hypotenuse leg. So now we have to treat it like any regular triangle. So looking at it as just a normal triangle, then what we have two angles and a side. Okay, so we have two angles and a side. So we have to decide, is it going to be angle, angle, side, or could it be angle, side, angle? Well, if it's going to be angle, side, angle, we need two angles and the included side, meaning the side between the angles. So let's see if we have that. So here we have this angle, okay, and then we have this angle. Now the included side would be this right here, but that's not what's marked, okay? So it's not the included angle, which means it cannot be angle, side, angle. Instead, it's the side that's, did I say included angle? It's not the included side, it's a non-included side. So that means angle, angle, side is the theorem that we want. So angle, angle, side. Okay, great. Now the congruency statement is, alright, so we have triangle ABC. A is the hypotenuse and the single. Alright, the hypotenuse and the single, that's E. Okay, B is the 90-degree angle, so that's F. So now we've done E and F, so that leaves D. Alright, and I thought there was more, but then nothing but blankness. So that was actually the last problem of the lesson. So I hope this was helpful, and I will see you on the next video.